number 11. Yeah, this is the problem number 11. Can you try what is the answer of this? So if anyone having any doubt, right? So in the group you can post. If anyone is not there in the group, this is my WhatsApp number, you can ping me. If anyone is not there in the group, it's my WhatsApp number, you ping me. It's my WhatsApp number, you can ping me. It's a problem number 11. It's a problem number 11. Yeah, what is the answer for this? Can you check? I will give the answer. Please write your opinion. Yeah, please check what will be the answer for this. I am here only. Yeah, so best idea is. Someone is saying options are more stretched. It's fine. It is an image. It's fine. Can you identify? Can you take one example and can you check? So I'm just giving one answer. S is equal to assume 1, 2. S is equal to assume 1, 2. Find out yourself power set of S. Find out yourself power set of S, so that you will get more clarity. Can you check one time? Yeah, that's what I'm saying. To get the clarity, can you solve this problem? This problem will give more clarity. Yeah, if you see the power set of S contain 2, power set of S contain 4. So let's see what are those. Empty set, only 1, only 2. Next one, only 1, 2. So this is totally 4. Next one, power set of S contain, that is 4 means it should be 16. That is 4 means it should be 16. Let me write, see this one. 1, 2, 3, 4. For this 4, 16 will come. Let me write few people. By default he will come. Next one. One element you take. This is the one element. This is one element. Next one, two elements, and so on. Total 16 will come. Now give the answer to me. Power set of S contain 16. Power set of S contain only 4. How both will be equal? So A cannot be. power set of S, power set of S. Common element is pi. Common element is pi. Common element is pi. So be correct. Next one, power set of S intersection. Power set of S intersection S is equal to power set of S. How it will come? Power set of S contain only 2 element. Power set of S contain 4. 2 people intersection 4 people. How 4 people will come? How it is possible? Next one, S belongs to power set of S. So S is the one of the element in power set of S. True. S is one of the element in, right? S is the one of the element in power set of S. True. So but he is saying it is not. That is the reason wrong. Now verify. So anyone having any doubt, let me know. Sir, I am facing problem in mathematical logic, right? So those problems also will come. First you revise whatever problems you have, please send to me. To this WhatsApp number you can send. To this WhatsApp number you can send. Anyone having any doubt, can you help? In all power sets, what is the common element? In all power sets, common element is this. In all power sets, common element is this. I am not saying that in every set common element. I am saying in every power set it is a common element. It is a common element. It is a common element in all power sets. In all power sets. It is a common element in all power sets. It is a common element in all power sets. So remember, power set of S contain one of the element S set. See, power set of S contain one of the element. Power set of S contain one of the element which is set. Power set of S contain one of the element which is the set. Power set of S contain one of the element which is power set of S. So I want to say one thing. This one. See this one. Power set of S is one of the element. Power set of S belong to power set of S. In the similar way, S is belong to power set of S. Are Rohit, are you okay? Rohit, are you okay? Okay, fine. Anyone having any doubt in this problem, please let me know. Anyone having any doubt in this problem, please let me know. Please let me know if anyone having any problem. Yeah, let's move to next problem. Right, let's move to the next problem. Yeah, what is the answer for this? Check. Let A be a set with n elements. Whatever dangerous problem you see, whatever dangerous problems you see in the DMS, in the discrete mathematics, whatever dangerous problems you see, please send to me. Please send to me whatever dangerous problems you see. That's my WhatsApp number. Please send to me. please send to me. That is my WhatsApp number. You can ping me. You can ping me. You can send all the doubts to me. You can WhatsApp me. Otherwise, I will add you in the group. In the group also you can post. Let C be a collection of distinct subsets. Distinct subsets. Of A such that for any two elements, for any two subsets S1 and S2 in C, either S1 is subset of S2 or S2 is subset of S1. Strictly subset. It is not subset or equal to. It is a strictly subset. Suppose if I take A as 1, 2, 3. Suppose if I take A as 1, 2, 3. Right? So I will take, right? So you know very well, so many subsets are there. It is A is having so many subsets. A is having so many subsets. Let's try, right? Few subsets here. Pi is one subset. S1. And one more thing, listen, one more thing, pi is one subset. 1 is one subset. S2. And one more thing is 1, 2, one subset. S3. One more thing is 1, 2, 3 is one subset. So if you observe clearly, S1 is subset of S2. S1 is subset of S2. S2 is subset of S3. S3 is subset of S4. Now, am I failed at anywhere this condition? Please check. Between every two people, S1 and S2, between every two people, S1 is subset of S2 or S2 is subset of S1. Any one should be satisfied. If A is equal to 1, 2, 3, C is the collection of distinct subset. It is the C. C is the distinct collection of distinct subsets of A, such that for any two subsets S1 and S2 in C, either S1 is subset of S2 or S2 is subset of S1. Then what is the maximum cardinality? He is asking maximum cardinality. I think maximum cardinality is, if at all, A cardinality is 3, I think C maximum cardinality is 4. 3 plus 1. A cardinality 3. C cardinality is 3 plus 1. You may say that, sir, why don't you write like this, sir? Some people may say that, sir, why don't you write like this one? Sir, C is equal to 1 here, right? C is equal to 1 here, right? 1 here, 1, 2, 3 here. If I write like this one, I will get only 2. I will get only 2. Some people are asking, sir, why don't you write like this? Why don't you write like this? If I write like this one, I will get only 2. If I write like this one, I will get only 2. It is the S1, it is the S2. It is the S1, it is the S2. I want maximum cardinality. Maximum cardinality is, right, if I take if I take a set with 3 elements, I will get the maximum cardinality 4. I will get the maximum cardinality 4. If anyone having any doubt, please let me know. So answer for this problem is, I think, B. Now come to question number 13. Question number 13. Yeah, who are isomorphic? Who are isomorphic here? I think if you observe clearly, isomorphic means everything should be similar. Isomorphic means way of drawing may be different, but every manner they both will be same. Can you verify here? These are same in every manner. See this one. I think here 6 vertices. Here 6 vertices. Next one, degree of everyone is 3 here. Here also degree of everyone is 3 here. Next one, how many edges here? Let's see how many edges. Let's see how many edges here. Let's see how many edges here. I think outside is 6. Inside is 3, 9. Here outside is 6. Inside is 3, 9. I think everything is fine. Now one small question I want to ask you. In the G3 triangle there. In the G4 any triangle. In G4 any triangle. In G3 triangle there. In G4 any triangle. In G3 triangle there. In G4 any triangle. G3 contain triangle. G4 having triangle or not? G3 having triangle. G4 having triangle or not? G3 having triangle. G4 don't have triangle. G4 don't have triangle. I think B is not the answer. A will be the answer. Right? Check once. G3 having triangle. See, G3 having triangle. But G4 don't have. It is having 3 length cycle. It don't have 3 length cycle. I think these two are look similar. It's a nice problem. It's a nice problem. Please take care. And one more thing you remember. Checking two graphs are isomorphic or not. Undecidable. We don't have any algorithm other than manual checking. Undecidable. Checking two graphs are isomorphic or not. Undecidable. Finding chromatic number. Undecidable. So other than manual checking, nothing there. So in G3, 3 length cycles are there. In G4, 3 length cycles are not there. Someone is saying 4 length cycles. 4 length cycles in G1. 4 length cycles in G1. I think in the G1 4 length cycles, if you see F to C, C to B, B to A. Are same yaar. See this one. Same G1, right? G1 take the F as the root. G1, if you take F as the root, same diagram, right? See, G1 diagram if you see, F as the source if you take, this side is E. This side is E. This side is A. This side is A. Remaining all in between. DCB. DCB. It is same diagram. Am I right? Am I right? Same diagram. Make F as the root. Make F as the root. Same diagram. Right? If you are unable to find out, it's not our problem, right? So that is the meaning of isomorphism, right? You may not able to do that. That is the reason it is undecidable problem. Small problems only he will give. Small problems only he will give. Big problems he don't give. If at all anyone will give big problem, no one will resolve. I also thought initially B is the answer. At the end we got to know A is the answer. Right? So if you see the G1 diagram, same story. F is the source. This side is E. This side is A. Remaining is DCB. Same answer, same diagram. Same diagram. Both are same, check. So here 3 length cycle is there. Here 3 length cycle not there. So answer is A. Answer is A. Yeah, let's move to the next problem. So it is undecidable problem. If anyone unable to do, for everyone same. Please practice. For everyone it is same. Please practice. Yeah, I think 13 is over. Go to the 14. 2, 1, 3, 4 will give 4 length. It's possible, right? 2, 1, 3, 4. Just increase one edge. Yeah, same diagram, yeah. Same diagram. Verify properly. Go to the 14. Can you try this? Go to the 14. So what is the answer for this? Graph contain this problem if you observe, graph contain V1 to Vn. So n vertices. Delta of G denote the maximum degree of G and let n is equal to 1, 2 and so on. Delta G denote the maximum degree of G. Okay. The set of all possible colors. And one more thing is these are the colors and let n is equal to these many colors are there. Set of all possible colors. Delta G is the maximum degree. Possible colors n is equal to 1, 2, 3 and so on. Color the vertices of G using the following greedy strategy. For I is equal to 1 to n, color of vertex Vi is equal to minimum of J belongs to n. No neighbor of Vi is colored J. Minimum J number. Minimum of J belongs to n. No neighbor of Vi is colored J. So can you help me one small line? According to this algorithm, what is the V5 color? It is a V1, it is a V2, it is a V3. Assume that its color is C1, its color is C2, its color is C3. So V5 color is going to be minimum number right? Which is not there to its neighbor, which is not there to its neighbor, to its neighbor, to its neighbor, right? C1, C2, C3 there. So the color which you don't have is going to be, I can write C4, I can write C5, but minimum number is C4. The color which neighbors don't have, the color which don't have neighbor and minimum one, I think C4. So like that is keep on doing. V3 color C1, V2 color C2, V1 color C3. What about V5 color? V5 color is going to be minimum number which neighbors don't have. I think minimum number is, I think, 4. 5 also, 6 also, but minimum number is going to be 4. So I think C4. Now I think that is algorithm which is following. Which of the following statements are true? GATE aspirant saying, sir, I completed 8 subjects with EM, APT, DLD and CD left out. Okay. Yeah, please complete at least important topics or pending subjects. Simultaneously do practice also. Simultaneously do practice also. Now he is saying that this procedure results in proper vertex color of G. This procedure results in proper vertex coloring of G. Yes, perfect. No problem. The number of colors used is at most delta G plus 1. Of course. The number of colors used is at most delta G plus 1. What is the delta G? What is the delta G? Denote the maximum degree of G. Delta G denote the maximum degree of G. Right? So he is saying that the number of colors used is at most delta G plus 1. Next one. The number of colors used is at most delta G. No. The number of colors used is equal to the chromatic number of G. The number of colors used is equal to the chromatic number of G. So chromatic number of G. Right? No, I cannot give guarantee because chromatic number is the minimum number of colors. The number of colors used is equal to the chromatic number. No, it may go more than chromatic number. The reason is this algorithm, greedy algorithm, there is no algorithm for this. To find out the chromatic number, there is no proper algorithm. It may give more colors. It may give more colors. Actually 3 colors required, it may give 4 colors. It may give 4 colors. So I think this is also wrong. This procedure results in proper vertex coloring of G. Okay. The number of colors used is at most delta G plus 1. The number of colors used is at most delta G. No. If it is a complete graph, delta G plus 1. The number of colors used is equal to the chromatic number of G. No proper algorithm. Chromatic number means minimum number of colors needed. So this algorithm cannot give minimum number of colors needed. This algorithm cannot give guarantee minimum number of colors. Chromatic number means minimum number of colors. So what is the answer for this one? Which of the following statements are true? 1 true, 2 true, 3 false, 4 also false. I think 1, 2. There is no proper algorithm. If at all this algorithm working, everyone will follow this algorithm. If at all this algorithm working, right, then graph coloring is going to be a decidable problem. It is not a NPC problem. If this algorithm is working, this will become not NPC problem, P problem. P problem is easy problem. P problem is polynomial problem. P problem is polynomial problem. One and 2 are true. Proper vertex coloring is fine, but I cannot give guarantee minimum number of colors. This procedure results in a proper vertex coloring of G. The number of colors used is at most delta G plus 1. Why do we want to color the graph? Because he is saying color the graph. But why do we want to color the graph? Right? He is asking, I will color. Yeah. So why do we want to color the graph? Yeah. If that is the case, I will color you. I will color you, not graph. I will color you. Then you ask me, why you want to color me? Then I will ask color your friends also. Then I will color your friends also. Right? If you ask me why to color the graph, I will color you. If you ask why me, I will color your friends also. Right. J Sonavani. Are J, what kind of name? J Sona Vain. I thought my name is complex. Your name is nonsense. Are J, I thought my name is nonsense. Your name is more nonsense. J Sona Vain. What is this nonsense? Nonsense name. Right. Which of the following statements are true? Yeah. Answer is 1, 2. So listen everyone now. Last year or before year this question came. Last year or before year this question came. So many people taken 4 also true. It is a MSQ. It is a MSQ. Right? Last year this question came. It is a MSQ. Many people taken 4 also true. The number of colors used is equal to the chromatic number of G. If it is the case, chromatic number finding is, right, NP, how it is NP complete? How it is NP complete? Last year this question came, many people give an answer as 1, 2, 4. 1, 2, 4. Right. Now come to the next problem. Question number 15. There exist A infinite sets A, B, C such that A intersection B union C is finite. There exist A infinite sets A, B, C such that A intersection B union C is finite. There exist A two irrational numbers x and y such that x plus y is rational. Which of the following is true about S1 and S2? There exist A infinite sets A, B, C such that A intersection B union C is finite. There exist A two irrational numbers x and y such that x plus y is rational. So I want to ask you one thing. There exist infinite sets A, B, C such that A intersection B union C is finite. There exist two irrational numbers x and y such that x plus y is rational. Now let me ask you one small line. You can arrange whatever. He is saying that 3 infinite sets, but result is finite. 3 infinite sets, but result is finite. How? Yeah, let's try once. So assume that right? Everyone listen, everyone listen. Let us assume A is a even numbers, 2, 4, 6, 8, 10, even numbers. A is even numbers. B is odd numbers. C is, right? C is prime numbers. C is prime numbers. C is prime numbers. So can you help me? Can you help me? So what is the result? A is a even numbers, B is a odd number, C is a prime number. So odd number union prime number. What is the answer? Odd number union prime number. What is the answer? I think all odd numbers. 1, 2, 3, 5, 7, 9, 11. All odd numbers will come. Odd number union prime numbers will give all odd numbers, because odd numbers are more. Odd numbers are more. Interesting thing is 2 also will come. 2 also will come. Now even number, right? These odd numbers, right? Do intersection. I think 2 common. 2 common. Odd number union prime number. So all odd numbers will come, and 2 extra also will come. 2 extra also will come. 2 extra also will come. So even number intersection, odd number you do, actually you will get pi. Actually you will get pi. But 2 is common in the prime number. In the prime number and even number, 2 is common. But anyhow, he is saying finite. If pi will come also, no problem. If pi will come, then also no problem. If pi will come, then also no problem. Pi will come, then also no problem. So S1 is true or not? S1 is correct. See the S2. Two irrational numbers x and y, if you add, result will become rational. I think that is fine. 2 plus root 5 plus 2 plus root 5, 2 minus root 5. If you add both of them, these are irrational number. I think plus 5 minus 5 cancel. It became 4. It is the rational number. Two irrational numbers, if you add, result such that result is became rational. It is a irrational. It is also irrational. Two irrational numbers, if you add, right, it became rational. There may be many examples. Gaurav, there may be many examples. There may be many examples. One example I given. Fine, can we go to next? Right. Fine, let's go to next problem. Problem number 16. Graph G obtained by adding vertex S to K34, making S adjacent to every vertex of K34. The minimum number of colors required to edge color of G is. The minimum number of colors required to edge color of G is. Yeah, so this problem I will do in tomorrow's class. We'll try tomorrow. Now, can we go to the next problem? Can we go to the next problem? Yeah, this problem. Try this. Yeah, we tried a lot. But it is coming big diagram. I think it is coming as more than 8 colors. More than 7 colors. Yeah, can you go to this problem? Let G be a connected planar graph with 10 vertices. If the number of edges on each face is 3, then the number of edges in G is. Yeah, go ahead. Let G be a connected planar graph with 10 vertices. If the number of edges on each face is 3, then the number of edges in G is. Yeah, what is the answer for this? Vertices 10. If the number of edges on each face is 3, number of edges on each face is 3, then the number of edges in G is. Can you help me now? Connected planar graph. Connected planar graph. What is the formula? Connected planar graph. What is the formula? V plus R is equal to E plus 2. Am I right? Connected planar graph. V plus R is equal to E plus 2. Yeah, fine. So tomorrow once again we will try, right? If it is a really difficult one, right? If any shortcut is there, anything is there, I will explain to you. I also tried, right? I also tried. I could have tried before only, but I thought it is the vertex coloring. Yeah, it is created some trouble. Any shortcut is there, some other method is there, I will explain to you tomorrow. Tomorrow I will do, right? Any edge coloring problems are there, including that I will do. Yeah, can you try this one? V plus R is equal to E plus 2 in the case of planar graph, right? Everyone know this one. If at all, right? So this is the formula, V value 10. Can you help me now? Number of edges on each face is 3. I think degree of every face is 3. Can you help me now? Sum of degrees theorem. What is the answer? Sum of degrees theorem. Sum of degrees of region is equal to, right, 2 into E. I think if at all number of faces, face means region. If number of regions are R, right, every region degree is 3. So 3 R. 3 R times is equal to 2E. Is equal to 2E. Right? The number of edges in G is asking edge value. He is asking number of edges. So let me write now. R is equal to 2E by 3. R is equal to 2E by 3. If the number of edges on each face is 3, so if the number of regions are R, so every region degree is going to be 3. So 3 R times, so 3R is equal to 2 into E. So R is equal to 2E by 3. R is equal to 2E by 3. So in this formula you please substitute V value 10, R is going to be 2E by 3 is equal to e plus 2. Yeah, e, small e or capital E doesn't matter. Right? So e bring this side. 2e by 3 minus e is equal to, right? So 2 will be this side only, minus 10. So if you common e, 2 by 3 minus 1 is equal to 2 minus 10. Please check if I done anything wrong. V plus R is equal to E plus 2. 3R is equal to 2E. R is equal to 2E by 3. So V plus R, right? R is replaced by 2E by 3. 2E by 3. Do calculations properly. So this is going to be 30 plus 2e by 3 is equal to e plus 2. So finally 30 plus 2e is equal to 3e plus 6. So if you send e that side, 30 minus 6 is equal to e. E is equal to 24. Do whatever way you like. Right? That is the answer. Check one time properly. Yeah. Can we move to the next problem? I am not done anything. Whatever information he given, I substituted. Sum of degrees theorem. Sum of degrees theorem. It is a planar graph. For planar graph, this is the property. First one is planar graph property. Second one is sum of degrees theorem. So I substituted there. 10 plus 2e by 3 is equal to e plus 2. So 30 plus 2e is equal to 3e plus 6. Finally, e value is 24. Can we move to the next problem? Let G be a planar graph such that every face is bordered by exactly 3 edges. Let G be a planar graph such that every face is bordered by exactly 3 edges. Which of the following can never be the chromatic number of G? Chromatic number means, remember, the minimum number of colors required so that, right, each vertex will be covered, right? So remember, chromatic number means vertex. That is the reason we done for vertex, right? Previous problem is related to edges, so some trouble there. Tomorrow once again we will see. Let G be a planar graph such that every face is bordered by exactly 3 edges. I think, can you help you now? Right? Degree of every region, how much? Degree of every region, how much? Planar graph only, every face is bordered by exactly 3 edges. So I think then which one of the following can never be the chromatic number? I think every region is, every face means every region. Yeah, is it fine now? Hello? Is it came? Is it came now? Yeah, come to this problem. So let G be a planar graph such that every face is bordered by exactly 3 edges. Which of the following can never be the chromatic number? So if that is the case, so this is the right. So like this planar graph is like this, 3 edges. So if this is the case, when you say that every face, every region degree is every region degree 3 means, I think there is a triangle. When there is a triangle, at least, right, and when there is a triangle, 3 colors compulsory, C1, C2, C3. So answer should be, chromatic number should be 3 or more. 3 or more. Chromatic number should be 3 or more. 3 or more. Either 3 will be there or more will be there. Because we didn't mention how many vertices are there. 3 or more. So 2 cannot be. 2 cannot be the answer. Right? 2 cannot be the answer. Right. Yeah. Go to the next one. Yeah. So try this one. This also try. Let D denote the minimum degree of a vertex in a graph. For all planar graphs on n vertices with D greater than or equal to 3, which one of the following is true? Can you try what is the answer for this? First you try. It may also trouble, please take care. It may also trouble you, please take care. Sir, can any valid grammar have only terminals in the left hand side? Maybe. So unrestricted grammar. Rohit, unrestricted grammar. Don't think much. Unrestricted means no restriction. Anything on the left, anything on the right. So different books are saying different things. Don't worry. Anything on the left, anything on the right. Unrestricted grammar saying no restrictions. Anything on the left, anything on the right. Yeah, type 0 grammar. Yeah, see this problem. I think it is like previous problems only, but small change there. Let me see this one. Previously, what he is saying is every person degree is 3, but here minimum degree 3. Let D denote the minimum degree of a vertex. It is a vertex, please be careful. Minimum degree is not given exact degree, minimum degree of a vertex. D is the minimum degree of a vertex. Let D denote the minimum degree of a vertex. In a graph, for all planar graph on n vertices with D means minimum degree D is greater than or equal to 3. Which one of the following? Because of in the problem is mentioned that D is the minimum degree for all planar graph and n vertices with minimum degree is more than 3 or more than 3. Right? Now let's see this. Let's see this one. Number of vertices are n. Number of vertices are n, and he is saying every vertex degree is minimum 3. So sum of degrees 3n is less than or equal to 2e. Every vertex degree is minimum 3. Sum of degrees 3n is less than or equal to 2e. Is less than or equal to 2e. So I want from this e value. How? 3n by 2 is less than or equal to e. So this is the equation number 1. See the next one. V plus r is equal to e plus 2. V plus r is equal to e plus 2. V means n. N plus r minus 2 is equal to e. Right? This is number 2. This is number 2. So, right? So, I think now see 1 and 2. Using 1 and 2. Using 1 and 2. Using 1 and 2. See what I am done. 3n by 2 less than or equal to, what is the e value? N plus r minus 2. Right? N plus r minus 2. Now this one is going to be 3n by 2. 3n by 2. You want faces, right? Minus n plus 2 is less than or equal to r. So finally it is going to be n by 2 plus 2 less than or equal to r. If you write in the reverse order, r is greater than or equal to n by 2 plus 2. So that is the answer for this. There may be many ways. I am just giving one way. Whatever way I felt, I done. Number of vertices are n. So minimum degree is 3. So 3n less than or equal to 2e. So 3n by 2 less than or equal to e 1. Because of planar graph, second one is started. So n plus r minus 2 is equal to e. It is the second one. Using 1 and 2, 3n by 2 less than or equal to, right? E place I written the e value. After doing all, I got n by 2 plus 2. So that means minimum number of faces are at least n by 2 plus 2. Is it okay? If it is okay, I can go to the next problem. See, some problems will trouble you. See, one problem already troubled. Right? Tomorrow we will trouble that problem. One problem already troubled us. Tomorrow we will trouble it. Tomorrow we will trouble that problem. Don't worry. I misunderstood that problem. I thought it is the vertex color, but it is the edge color. By God grace, right? Unknowingly it is a edge color. Right? I will check one time, you will also check one time. Tomorrow we will solve it again. Can we go to next problem? 18 problems we done. Go to the 19th problem. 19th also we done. Go to the 20 problem. Problem number 20. Go to the problem number 20. Yeah, I think this problem we done many times. Can you say what is the answer of this? Embedding means nothing. Planar embedding means planar graph. I think we done this one many times. So bipartite graph, see this one, 12 vertices bipartite. So you can divide whatever way you like. 12 vertices bipartite, you can divide whatever way you want. Minimum 1 here, 11. So number of edges are 11 only. 2 here, 10. Number of edges are 20. So 6 here, 6 here. Number of edges are 36. 7 here, 5 here, 35. 7 5s 35. And so on. Lastly, 11 here, 1 here. So 11. So when you do equally, you will get the more edges. When you do equally, you will get the more edges. Suppose equally not possible. 13 vertices equally not possible. 6 7s or 7 6. Close to equal. Either equal or close to equal. So Parthi saying, sir, when will you start CN? This is the human problem. When discrete maths going on, CN. When CN going on, discrete maths. Human nature is like this. Human nature is always like this. When DMS going on, when is CN? When CN going on, when is DMS? When CN is going on, one dog will ask me, what about DMS? Right? So let's go to 21. After 21, I will stop. Let G be an arbitrary graph with n nodes and k components. If a vertex is removed from G, the number of components in the resultant graph must necessarily lie between. Remember, graph contain already n nodes and k components. Graph contain n nodes. Graph contain n nodes. Graph contain n nodes and k components. N nodes. Component 1, component 2, component k. K components. N nodes and k components. And he is saying, if I delete one vertex, then how many components can come? From above graph, delete one vertex. Delete one vertex. Then minimum components how many can come? Maximum components how many can come? From the above graph, n nodes k component graph, if you delete one vertex, minimum components how many? Maximum components how many? In this problem, what is the minimum k value? In this problem, minimum k value, k components and n nodes. Read the problem. K components, n nodes. What is the minimum k value? 1. Minimum k value 1. Minimum k value 1. Right? Now see this. Minimum k value 1. Yeah, see this one. It is the minimum k value 1. So if you delete this person, this one component become n minus 1 components. If you delete this person, one component become n minus 1 component. So one more graph let me take. Yeah. So in the first graph, if you delete this person, right, k components become n minus 1 components. In this one, component 1, component 2, component 3. If you delete this one, number of components will decrement by 1. Previously k components, now k minus 1 component. Previously, one component there. K is 1. Previously k is 1. But when you delete this node, it became n minus 1. Previously k value 3. When you delete this node, it became 2. So the answer is going to be minimum. Previously k components, minimum become k minus 1. Previously k components, now after deletion, maximum is n minus 1. K minus 1 to n minus 1. See. K minus 1 to n minus 1. How k minus 1? See this one. Previously one component. When I delete this one, all became 1, 1, 1, 1. So n minus 1 components maximum. Yeah, star graph. Maximum these many. Minimum how many is? Number of components previously 3. Now one person you deleted. It became 2. 1 decrease. Minimum 1 will decrease. Maximum n minus 1. In between anything can happen. And one more, this problem also everyone know. A graph is a planar graph if and only if. A graph is planar graph if and only if. You know very well. If any graph you want to say planar graph, listen. Any graph if you want to say planar graph, inside this graph, I don't want K5. I don't want K5. I don't want K33. If you want to say some graph is planar graph, I don't want K5, I don't want K33, a subgraph. I don't want inside this graph K5 or K33. See, both cannot be there. See, so both cannot be there. This one cannot be there, this one cannot be there. One also there, it is fail. K5 cannot be K33. Listen everyone now. A graph is planar graph if and only if it does not contain subgraph isomorphic to K5 K33, homomorphic to K5 K33. Do you know difference between isomorphic homomorphic? Do you know between isomorphic homomorphic? We done many times. Do you know difference between isomorphic homomorphic? Do you know difference between isomorphic homomorphic? Do you know difference between isomorphic homomorphic? See this one. This is called as isomorphic. Isomorphic means exactly. Homomorphic means, right, some subdivisions are there. Homomorphic means some subdivisions are there. One edge becomes more edges. Same structure, one edge become more edges. Nothing there. Same structure, one edge will become more edges, subdivisions of edges. Vertices are increasing, edges are increasing, subdivision. See this one, even though here so many vertices, so many edges, it look like K5. This is called homomorphic. It look like K5, but in between so many vertices are there, so many edges. If you can find any graph, subdivisions of K5, exactly K5 are subdivisions of K5, exactly K33 are subdivisions of K33. then it is not a planar graph. If you want to say some graph is a planar graph, right? Homomorphic to K5, K33, isomorphic to K5, K33. Yeah, both are similar. Both are similar. Please careful. Different way of saying. You know the difference between homomorphic, isomorphic. Homomorphic, isomorphic. So everyone know K5. K5 exactly everyone know. It is not K5. It is homomorphic to K5. This is not K5. It is homomorphic to K5. This is K5. It is isomorphic to K5. This is isomorphic to K5. It is a homomorphic to K5. Be careful. Yeah. Now what is the answer for this? Can anyone help me? What is the answer of this problem? A graph is a planar graph if and only if it does not contain a subgraph homomorphic to K5 and K33. Which option? Can you help me now? Will you take homomorphic or isomorphic? Need not be exactly K5. Need not be exactly K5. Homomorphic to K5 better. Looks like homomorphic is saying that look like K5. Look like K5. Look like K5. So can you help me know which option? Homomorphic is the better option. Homomorphic will cover many. K5 will cover K5 only. See, isomorphic to K5 means only K5 you will take care. Now I will ask you one small line. Can anyone help me now? I will ask you one small line. I will ask you one small line. Everyone give the answer. I will ask you one small line. Everyone give answer. Yeah. So please give answer. Please give answer. In all these diagrams, which one is? In all these diagrams, which one is isomorphic to K5? In all these three diagrams, which one is isomorphic to K5? In all these three diagrams, which one is isomorphic to K5? In all these three diagrams, which one is isomorphic to K5? In all these diagrams, which one is isomorphic to K5? Only second one. Which one is homomorphic to K5? Which one is homomorphic to K5? All. Homomorphic will cover isomorphic also. Isomorphic don't cover homomorphic. See this one. These all are homomorphic. All are homomorphic. The isomorphic is only this. These all are homomorphic, but isomorphic only be. Homomorphic is a superset. Homomorphic is superset. Isomorphic is a subset. So, will you go for homomorphic or isomorphic? Homomorphic. Can you help me now? Only K5. See this one. Homomorphic to K5. It is not planar. Homomorphic to K33. It is not planar. See this one. Both not. Listen everyone now. Both not there. Both not there. It is not planar. One also there. It is not planar. Both not there, then also not planar. One is there, then also not planar. So answer is 4. K5 which does not contain K5 or K33. Option 1 is saying that, 3 both cannot be there. Option 1 saying that both cannot be there. Indirectly option 1 saying that K5 is there, no problem. No. Which does not contain K5 or K33. Which does not contain K5 or K33. Option 1 saying that which does not contain both. Option 1 saying which does not contain both. So option 1 indirectly saying 1 is there, no problem. Option 1 saying that 1 is there, no problem. No, both cannot be there. Which does not contain K5 or K33. Remember, this will take care. This will take care. K5 and K33. Only K5. Only K33. This will cover 3 possibilities. But it will cover only this. So answer is 4th one. First keyword is homomorphic. Second one is which does not contain K5 or K33. According to first option, both not there. Then only it is a planar. But if one there, only one there, according to first option, it is a planar. Only K33 there. According to first option, only K33, then also planar. Only K33, option 1 saying that it is a planar. Only K5, it is a planar. No, if both 6, no one should be there. Neither K5 nor K33. So it is a nice question. See, these kind of questions will come in the exam. They don't take, gate exam problems don't take more time. Gate exam problems don't take more time. See, what is the use of this kind of problem? It is taking a lot of time. This problem, the problem which troubled us, it is taking a lot of time. What is the need of giving these kind of problems? If anything nice, we will see. If anything is nice, we will see. But these kind of problems, what is the use? It is taking a lot of time. We tried half an hour, it is not coming. What is the use of those kind of problem? There should be a small twist. Problem should be as simple as possible. There should be a small twist. Yeah, there should be a small twist. So if any problem is very danger, it look like a very danger, you no need to study that. When you are preparing, some questions are really troubling you. You no need to think that much because right, that kind of in one paper, one question only there. Out of 10 questions of discrete mathematics, one question may be really tough. You no need to waste that much time. If you are unlucky, one question may be tough. If you are unlucky, right, one question may be tough. Suppose more questions are like that, then question paper is very tough. Very less marks, right? Very less marks also you will get the good gate rank. Anyhow, because of that problem is trouble, tomorrow we will solve it again, right? Fine. Until now, see this one, 22 problems I covered. This is a nice problem, please take care. See, R operator, this AND operator is indirectly saying that both not there, then it is a planar. If one is there, then also planar. Both not there, then planar. Indirectly saying one is there, then planar. No. One is there, it is a planar. So he is saying that Three combinations. Both there it is not planar, one there it is not planar. But he is not talking like that. Right? Fine. Tomorrow we will see remaining problems. Thank you so much.